Mr. Rops.
And Mrs. Flynn.
And we're here to do some more on parallel and perpendicular lines. So here's a scenario we have. An equation of a line that passes through the point 2, 4 and is perpendicular to 3x minus 2. Do you want to do a quick sketch of what we're actually going to try and find?
Sure.
Okay.
So, I'm better using lines, or I know how you get to. There's our line. Zap.
Very nice.
And if we have, wish I could change color.
It's really thick that way.
It is really thick, but 3x minus 2, I know my y-intercept's at -2, so it's going to be down here. It's a positive slope.
Right.
So I have something looking like this.
A little bit higher up that way because it's 3.
Ah, yeah. There we go.
Okay. And so if we want the point 2, 4.
So 2, 4, and we want it to be.
Not necessarily. I don't know. We just go 2, 4. We want a perpendicular line through it, kind of thing. So 2, 4, and then we'll just cut through. Oh, excuse me.
So right here.
Something like
well,
no.
that's not perpendicular.
There we
There's
go. Perpendicular.
Okay. So here, our slope here is 3 in this equation.
Oh, right. There's our slope. Exactly.
But we want to know it's perpendicular.
Right. So that means the perpendicular slope, we have to do the opposite reciprocal.
So -1/3.
Okay.
Well, now look, we have a point
Ooh.
and a slope.
Ooh.
Well, that makes it really easy.
Yeah.
We can go y equals mx plus b. Put in this equation.
Yep.
4 equals -1/3. X is 2 plus b.
All right, so now we have 4 equals to -2/3 plus b. Adding the 2/3.
So what is our y-intercept?
4 and 2/3, so that's going to be 14/3.
You're faster than me. So our equation?
Y equals m is -1/3 x plus 14/3. Okay, let's check that in our calculator there.
All right, there's our original equation. To put in our new equation, we have -1/3 x plus 14/3. We hate graph.
There we go, they are perpendicular. Now one of the things that you should probably realize, if you do it in your calculator, it may not look perpendicular. What we have done is we zoomed to number 5, which is square, which makes everything look in the direction it's the shape it's supposed to be. So that's a neat little trick to see things look in the right proportions.
Good tip. Okay,
Good tip.
next one.
All right, find the equation line that passes through 1, 4 and parallel to 3x minus 2.
So now we still have y equals 3x minus 2 with the slope of 3. If it's parallel, train tracks.
Yes.
That means our slope is still going to be
3.
but it goes through this point, 1, 4. Easy enough.
All right, we plug y equals mx plus b is our thing. So we have y equals 3x plus b. So we plug our 4 in for y, our 1 in for x, plus a b.
Ooh, this one's easy.
No fractions.
B is 1. So our equation would be?
Y equals 3x plus 1.
That makes sense because it has a slope. And let's see, let's check it over here.
Okay.
So here's our original equation. Go to the next one. And we have 3x plus,
Oh, we missed the x.
plus 1. And graph it.
Train tracks, hooray!
Beautiful. Okay,
All right,
that's
sounds
it.
good.